So to most people, I would say the possibility of life on Mars, or even in extreme conditions here on Earth, basically falls into the same category as most of what's on YouTube. Interesting, exciting even, but maybe not that relevant to everyday life. But I think most people would be surprised to discover how far-reaching the consequences of these discoveries can be. In particular, one example that I feel is often overlooked is the benefit to molecular biology. Biotechnology, as you know, is becoming increasingly prevalent in our world, although not without its share of controversies. But regardless, this revolution would not have been possible were it not for one otherwise obscure molecule, Taq polymerase. Taq, as it's known, was first isolated in 1965 from the extremophile bacterial Thermus aquaticus, which is found in the hot springs of Yellowstone. And its function is that it allows the bacteria to replicate its DNA even at relatively high temperatures. But it remained a footnote until the early 1980s when a biochemist named Kary Mullis realized that he could take advantage of the fact that DNA denatures, that is, splits into separate rungs at high temperature, by using Taq to replicate these split halves. Once the reaction is cooled, the DNA binds back together, except now you have two strands which can then be split and replicated again, yielding 4, then 8, then 16, and so forth. Thus, by repeating the reaction, the amount of DNA replicated grows exponentially in a relatively short amount of time. And this was a massive breakthrough because previous methods of replicating DNA were slow, expensive, and complicated, and the polymerase chain reaction, or PCR as it became known, was vastly cheaper and simpler. So because of Thermus aquaticus, this bacteria that lives in a place that hardly anyone would call hospitable, suddenly all these things became possible. Easier tissue typing, the coding of the human genome, genetic counseling, and arguably, in my opinion, most important, CSI Miami, which, let's face it, would be a far less interesting show without the frequent use of DNA fingerprinting. Now, this is where the search for life beyond Earth comes in, because compared to the conditions we might find on, say, Mars or Europa, the hot springs that produce Taq are downright pedestrian in comparison, and anything that might possibly be living there is going to have probably even more impressive biochemical adaptations that could have incredible value for medicine, biochemistry, and the understanding of biological life in general. So life on Mars, even if it's the most primitive of microbes, will be a treasure trove, and you might even say that the resulting new techniques and technologies would be positively out of this world.